Hello, Innovation Stream friends. Wherever you are in the world, I hope you and your loved ones are healthy and safe. My name is Randy Bell, and I'm the director of the Global Energy Center at the Atlantic Council. Thank you all for joining us for EnergySource Innovation Stream today, where we highlight new energy technologies with the potential to reshape the global energy system. We held our first Innovation Stream episode 1 year ago yesterday. So effectively today is the 1 year anniversary. And what a year it has been. This is actually our 40th Innovation Stream event. I want to give a huge shout out to Olga Kokova for making each of these episodes happen over the past year, and to the Atlantic Council events team for making each one of these come off seamlessly. And I also want to thank our loyal audience for continuing to tune in week after week. Today, we will be hearing from Dr. Doug Baer, Global Product Line Manager for Laser and Analyzers Measurement and Analytics at ABB. Doug is going to discuss how ABB's gas leak detection technology identifies leaks throughout the entire natural gas supply chain with high reliability and speed. This couldn't be more timely given the conversations in the Senate about utilizing the Congressional Review Act to undo the Trump administration's relaxation of methane regulations. I have several reminders before we get going. First, you can follow us on Twitter at AC Global Energy and use the hashtag InnovationStream. Second, after Doug's presentation, you can submit questions through the Q&A function on Zoom, and I'll try to get to as many of these as I can. If you're watching on another platform like YouTube, unfortunately, we can't take your questions there. So please let me welcome Doug to the Atlantic Council. Doug, thank you so much for joining us today.
That's a pleasure, Randy. Thank you.
So how have you been holding up over the past year of this strange 2020 into 2021, and how has COVID impacted ABB's business?
So anyway, I've been holding up fairly well. We don't really refer to it as work from home. It's more like living at work. Um, so we are constantly working and continually developing a new and exciting products and solutions. So we haven't really slowed down at all at ABB.
That's fantastic. And what you're doing is really, really exciting, and of course going to be incredibly relevant as we think about the role of natural gas in the energy transition. So
Absolutely.
why don't you get started with your presentation, and we're really looking forward to hearing from you, and then we'll come back to Q&A in a little bit.
Sounds good. How does that work?
We're not seeing the presentation quite yet. There we go.
All right. Well, it's a pleasure to be here, everybody. Thanks for joining. Today, I'm going to be talking about a comprehensive set of mobile gas leak detection solutions offered by ABB, essentially to reduce risk, increase safety, and decrease waste, making us all safer. Effectively, there are three primary reasons for improving the integrity of the entire natural gas infrastructure, and it includes safety, efficiency, and environmental responsibility. And in so doing, we hope to respond to the newly passed Pipes Act of 2020. In brief, aging pipelines and storage facilities present explosion risks, as everybody knows, which threaten the public confidence in utilities and as well as in the entire oil and gas industry. And then effectively, it limits the utilities' abilities to raise rates. Efficiency, by law, industry is required to monitor and inspect millions of miles of pipelines that are leaking, and this results in wasted product, which means lost product profits for everybody. And of course, as everybody knows, methane is a long-lived greenhouse gas, which is more potent than CO2. And so in order to meet local regulations called the Pipes Act, we must monitor and reduce our methane consumption. Some of you may be familiar with existing legacy techniques that have been used to monitor leaks. These conventional methods that use portable sensors can only see relatively large, like ppm level changes in the background levels of methane, and so and in addition, they're very slow to respond. And this is a problem when looking at leaks or trying to find leaks, because you must walk along the pipeline very slowly to find them. And especially if a leak emissions location is relatively small, such as like an inch in diameter, you could totally miss the leak unless you're standing right on top of it. All these old methods use paper-based recording, which is slow, laborious, and prone to errors. Our next generation ABB systems record data digitally. The diagram on the right illustrates the idea for mobile monitoring, which has been around since the mid-1990s. This is an example from a paper in 1995 outlining the idea. At the time, it was very difficult to perform these measurements because the instruments had to be performed in a semi-truck. So that's, let me just outline that. So this is the truck filled with existing instruments. You drive around, you look for the presence of leaks or tracers, and then you report the data. It wasn't really all that effective. But with our modern solutions deploy readily manufactured and easy to use gas sensors. The entire system includes analyzer, a GPS system, a sonic anemometer to measure wind velocity, an air inlet, and analytical software that ties it all together to report data in real time. ABB features one technology which I'll describe in the next slide, but this is a patented technology that we use in all of our analyzers for detecting, finding, quantifying, and then mapping these natural gas leaks, or just methane if desired, while either driving with a solution called MicroGuard, walking with a solution that we call MicroGuard, flying on a UAV, kind of the headliner of this presentation, called HoverGuard, or stationary, which is called HoverGuard. And now, in response to customer demand, in addition to selling a product, ABB offers leak detection as a service in certain regions like the US. All of these individual advanced leak detection solutions respond accurately to changes in the background methane in air as small as a few parts per billion, not parts per million, but parts per billion. And what this means is it allows you to detect leaks faster and farther from the source and with higher reliability. So no commercial solution presently is more sensitive or more precise. In addition, these respond very quickly to dynamic changes in the gas concentrations and to report the data very quickly to operators to find, enabling them to find more leaks in far less time than conventional methods allow. Virtually no warm-up time is required, so users can basically start collecting leaks as soon as the computer boots up. And at the end of a survey, it generates a detailed quantitative digital report that comprehensively summarizes the results obtained over a particular time interval or survey. These reports can be made available essentially immediately to a cloud-based secure server, always controlled by the customer, and thus to anybody, anywhere with granted access. This allows customers to find and fix leaks and prioritize those leaks that they fix quickly, and that saves time and resources. All of these solutions have passed rigorous cybersecurity requirements. So a very brief description of the technology. The idea of using a tunable diode laser to sense a gas has been around for 20, 30 years, maybe even longer. Basically, you take a tunable laser, you shine it through a gas cell containing the gas that you want to measure. And the fractional absorption or fractional transmission, either way, is due to a couple of different things that are monitored, like pressure and temperature, which you can monitor, and then the product of the path length times the gas concentration. These techniques, while effective, they're selective. They only sensitive to the gas that you're looking to measure. But because the path length is relatively small, you can only see parts per million changes in the background level. ABB's patented technology, on the other hand, replaces the windows with high reflectivity mirrors, effectively trapping the light so that it propagates kilometers length of path instead of just centimeters or even several meters. So as a result of our kilometers longer path length, we can detect far less gas in the cell than conventional technologies. In addition, because our laser beam is oriented at an angle, the exact trajectory is not that important. So that means the system is inherently rugged and that we can operate it in a truck, in a car, underwater, in a plane, or wherever without vibration issues, because there's no hole in the mirror for the beam to get in and out to. The beam actually propagates through the mirror because it's partially transmitting. Otherwise, it's the same. We tune the laser over an absorption feature of methane, and we quantify the gas concentration as a result. And all of that is done digitally and in real time. First, the solution that I'll talk about that employs this kind of technology is called MicroGuard. The MicroGuard solution is a driving-based solution that consists of 4 physical subsystems that operate in almost any vehicle. The methane-ethane analyzer, which is generally positioned in the trunk or the back seat, a GPS antenna, a sonic anemometer to measure the wind velocity, which helps indicate where the gas originates from, and a custom 3D printed proprietary custom air inlet mounted on the front bumper designed to allow operation even during rain and snow. And then a computer software communication system to analyze all the data in real time and to present those detailed results immediately to the user, and then securely share them to the cloud. We measure both methane and ethane so that we can attribute the emissions to natural gas or a biogas source, let's say from a landfill or animal or other source. So this gives us the selectivity that we need. MobileGuard can operate and record data while driving at highway speeds, although typically 20 to 25 miles per hour is typical. And unlike less effective mobile methods that require a vehicle to be near the source, we can detect leaks very far from the source, and that enables us to find them much faster than you used to be able to. The software utilizes advanced analytics based on complex fluid dynamics models and sophisticated data analysts to quickly ascertain the likely locations of the leaks, the leak attributes, as I mentioned, whether it's natural gas or biogas, and the effective area surveyed, basically upwind. And then we also provide quantitative estimates of emissions rate or leak size for each indication. And we display all this information clearly on a visual, easy to read, and graphically rich user interface as displayed in this slide. The user interface gives a detailed display of all the information. It will only briefly display basically on this plot. You have all the different data files that are recorded. You get the route of the car as it's driving, and then you get these spikes of methane and ethane that show up on the map, and it calculates the likely locations of the suspected leaks after you've done a couple of different rounds over a suspected area. That's MobileGuard. But what we've learned after driving MobileGuard, we give these emission indication search areas to the handheld to pinpoint, to the ground team to pinpoint, and we found that oftentimes they couldn't find the leaks because they were using insensitive equipment to actually find the leaks. So conventional technology is insufficient to find the leaks quickly. So we invented our own technology that we call MicroGuard, and that's based on the same technology in MobileGuard, but it's battery powered, handheld, and it's super fast. The MicroGuard solution incorporates the same technology in MobileGuard to precisely pinpoint the actual leaks while walking. This novel solution incorporates a lighter battery-powered analyzer that I just mentioned, the proprietary air sampling wand that you hold around, and the sophisticated software that operates on an Android phone or tablet. The MicroGuard software serves as a wireless user interface that is pretty simple to use, and it's easy. It's able to download, read, and view the geospatial maps generated and shared to the cloud by MobileGuard. And then it allows users to incorporate notes, maybe they're written, audio, or photos, or video, into a live report during and after each walking survey. It generates comprehensive, detailed digital reports that summarize all of the results automatically after each survey, and then you can share those reports to the cloud. The high precision and fast response allows our systems to find leaks in less than 5 minutes, whereas in other technologies, it used to take 45 minutes. So saving time, saving money at the same time, and finding leaks with a lot more certainty. This diagram displays and summarizes the results described in a walk package report generated after the walking investigation with MicroGuard. In this investigation, a walking survey first downloaded from the cloud a map and data from a recent MobileGuard investigation, which included the gas leak emission source within the yellow shaded area. Then the MobileGuard drive path is illustrated by this curve here. The path driven by the car is illustrated right here. So then the investigator started the route near the bottom of the center of the map as shown, and they were able to find the location of the leak within 5 minutes after starting this particular project. We've repeated this type of investigation several times and gotten similar results. But not all measurements can be performed while driving or on foot. So to address applications requiring measurements in locations inaccessible by the road or walking, we further reduced the weight and size of MicroGuard analyzer to allow it to mount on a commercial UAV or drone to create HoverGuard. This allows surveyors to investigate, find, map, and quantify leaks while flying near bridges, storage tanks, places with difficult right-of-way restrictions or otherwise difficult to access. The HoverGuard subsystems are like those in MobileGuard. They offer the same performance advantages as well as the mapping and reporting capabilities of the MobileGuard and the entire platform. High speed, sensitivity, selectivity, time response, and the ruggedness that I talked about. Many pre-production versions have been validated in independent tests worldwide from the US, Canada, UK, France, China, the Arab Emirates, Singapore. And then the bullets listed here are essentially the same performance attributes for MicroGuard which isn't really surprising because it's the same analyzer. And quickly, here's just a video of the MicroGuard, the HoverGuard in operation in a city park and showing its operation while flying. Usually there's a separate pilot that operates the UAV, and then there's a separate controller that's looking at the leaks as shown, as detected by HoverGuard. In a blind studies reported are conducted at METEC, which is in Fort Collins, Colorado Springs University, HoverGuard was able to demonstrate over 90% detection efficiency of finding leaks, even while flying 10 to 20 meters above the suspected source. 100% of the leaks were found above a leak size of 3 standard cubic feet per hour, and close to 90% of those, even as small as 1 standard cubic feet per hour. And this is a picture of some of the UAVs that were using ABB technology at this particular study. Interestingly enough, we applied HoverGuard for an under-river pipeline in the New York River. There was a pipeline that was overpressurized. They wanted to inspect for possible damages. Conventionally, they look for bubbles coming up to the surface. So we took HoverGuard and then did a lawnmower type pattern back and forth, and we finally found the bubbles just like the conventional technique, but in far less time. And we saw that the pipeline was actually okay. But in the same time, we found a known leak very far away at the particular storage facility. So people were actually extremely impressed by our ability to detect leaks even while far away. Recently, we deployed HoverGuard to record measurements above an abandoned, uncapped, and undocumented and uncharacterized gas well in Northern California. These results, which are particularly shown here on Google Earth, illustrate that HoverGuard was able to find the well location that we were looking for in the suspected source that we were aiming at, but it also found an unknown source that was many times bigger than the known source that we were targeting to investigate. And this site was basically, it's a site of several old oil and gas exploration fields with a lot of different abandoned wells. And this gives you an idea of the type of the size of the mystery site that we found that nobody had yet seen before. The bubbles that you're looking at that are coming out of the pond are pure methane, and we don't really know the source of it yet. These results were just recorded just 3 weeks ago, but as you can see, the bubbles are quite substantial, indicating the very sizable source of leak, and that's HoverGuard flying over and recording measurements while we speak. So to summarize, ABB offers a wide portfolio of high-performance, advanced leak detection solutions that basically address the Pipes Act of 2020 by detecting, mapping, quantifying, attributing, and finding these natural gas leaks for practically any application. I know I'm running out of time. I want to leave time for questions, so I'm going to stop there and open it up for any questions that you might have. Thank you very much.
Thanks so much. That's really, really fascinating. Very, very cool technology. Very could be quite impactful. We are starting to get questions in the Q&A, and I will get to those. Remember, if you do have questions, please put them in the Q&A. But a first question from me is on price. Most of the literature on methane suggests that at least a number of the leaks, many methane leaks can, if fixed, actually pay for themselves. But I want to talk about how your technology, particularly HoverGuard, but all these technologies fit into that equation. Do you see them paying for themselves over, is it a year? Is it 3 years? How long does that?
What happens, right? So that's a great question and something that we get all the time. And our systems cost more than conventional technology does. However, they find more leaks and much faster at doing so. So the return on investment, if you will, is typically between 6 and 9 months because of the number of leaks, and the reliability in which we can find those leaks is improved dramatically.
That's really remarkable. We've got a question from Brian Kelly, who asks where you are using this. Is it globally or just the EU and the US, or where is this technology being deployed right now?
We're actually deploying it on every continent, yet not yet in Antarctica, but not to be cheeky or anything, but yeah, it's a worldwide release. Every country is can receive this solution if you're interested. Yeah.
Okay, fantastic. Another really good question from Jeff Weiss, more about the HoverGuard, and he asks, you can address restrictions on UAV use and your
Yeah.
thoughts on the near-term future for broader UAV use for this purpose,
Right.
particularly.
That's right. So existing UAVs require an FAA approved license, and so it can only be flown within the line of sight. So the drone can't go beyond the line of sight using present FAA ruling. We believe that will change over time. We believe that advanced drone technology will allow safe operation even beyond the line of sight. So we're anxious for that. Um, Fortunately, we don't have to lead that effort. There are larger enterprises that are involved in pushing that regulation forward, and we will piggyback on top of those.
Got it. Thank you. We've got a really good question from Christoph von Eichhorn, which is how does HoverGuard and your other technologies compare to methane detection from space? Do you see them as ultimately competitors, or do they complement each other, or how do you see that working?
Right. So satellites are cool, a very interesting way of detecting very large leaks from space. They're looking at a column density of signal, basically a path average over the column of air that you're looking at. So it doesn't tell you exactly where the actual leak is. It tells you that there's a lot of methane, or more precisely, there's a lot of high column density of methane, which is the product of path length times concentration. So it doesn't tell you the exact three-dimensional plume characteristics nor the location of the leak. So in that regard, we are the ground truthing aspect of the satellite that gives you a sense of this large leak. But the satellites are great. They cover the Earth, and it gives us a sense for the larger emitters that can tackle. But ours allows you to actually pinpoint just about any leak anywhere, just no matter if it's a big leak or a small leak. So we're complementary. We are the ground truth, if you will, and allow the ability to actually pinpoint the location of the leak and fix it fast.
Got it. Where do you see your technologies being deployed first? Is it sort of the large producers? Is it at the wellhead? Is it in the midstream? Is it in residential neighborhoods? Where's the most interest right
Yeah,
now?
we already have a few dozen mobile guards in the field operated by utilities and people who operate distribution pipelines, if you will.
Mhm.
And we're getting into the midstream and upstream wellheads and transmission pipelines as we get more maturity and we get propagate further into the market. So we're targeting the entire natural gas infrastructure from the wellhead all the way down past the burner tip because it's leaking. So it's throughout wherever unwanted methane or natural gas might be emitted. We see ourselves providing a solution to address.
Got it. Jean-Paul Grouffay asks about HoverGuard and wants to know if the drone needs to be specifically engineered to work in an explosive atmosphere. So could any
Great.
work, or what do you need to do to make sure that it can work where you're dealing with a lot of methane?
Exactly. So we, because of our sensitivity, we can detect and the presence of a leak very far away. So well outside the explosion zone or the plume. And remember, to get to the explosion limit of methane in air, it has to be above 5% methane in air, and that's 50,000 ppm. Whereas our ppb level sensitivity plus the combination of measuring the wind velocity allows us to predict through our plume dispersion models the locations of those leaks, even flying far away. And far away, mind you, can be 10 or 20 meters away because the
Mhm.
plume, as big as it might be, gets diluted rather quickly in air. So we can get really accurate measurements, even if the enhancement is only in the order of tens or hundreds of ppm, well outside the flammability limit. So, and moreover, there's really no UAV that's going to be ATEX or explosion proof because I mean it's got these rotors and these motors and something like that. So the drone is always going to have to be away from the explosion area of the plume, but that's not a constraint whatsoever because we don't need to be near that to detect or predict the location of the leak.
Got it. Brian Kelly has another good question, which is, are you trying to uh, tie this to other ABB efforts in the upstream, midstream, and downstream programs? Do you see this as part of sort of an integrated solution for ABB?
Yeah, so ABB services the entire oil and gas infrastructure, and providing measurements of get oil and gas quality, and so we service, regularly all of the different upstream, midstream, and downstream um, customers. So we certainly complement those, and that's why we can actually piggyback on top of those efforts and service our customers regardless of where they are in the infrastructure chain.
Got it. What do you see are the biggest obstacles to deploying this technology? What would help unlock this technology and make it, more people adopt it, more
I think
companies?
honestly it's just an awareness of what's out there. It's a new technology. It's we're the automobile that's replacing the horse and buggy, and so people need to get comfortable with that. The light bulb replaced the candle, and people were initially fearful of that, and so, but once they see it in operation, once they see the ability to detect and then find the locations of the leaks and then quantify them, then the light comes on and people understand that this is a better mousetrap and we can actually utilize it. So it's an awareness. It's we offer demos all the time. Try it before you buy it, see what you're getting into, and then we believe it's a compelling argument after that.
Got it. Okay, it's still a new technology, but I want to look into the future even farther. We're talking
I'm
about
sorry,
the
let me
future.
correct that. Let me backtrack a second. It's a new technology for this application, but
Yeah,
the
got it.
technology itself has been employed for over 2 decades.
Right, right. So a new product using old technology. Um, but I want to look into the future. We're talking about potentially a hydrogen economy in the future that could include hydrogen blending into the gas pipelines. Could mean hydrogen pipelines of their own. How would your system work if hydrogen is blended at 10 or 15 or 20% into the gas pipeline? Could you ultimately detect hydrogen leaks versus
Yeah,
methane? And then if you're looking at a pure hydrogen pipeline, could you detect hydrogen leaks where the explosive risk is even greater?
right. So great question. So hydrogen not being a greenhouse gas, if you will, it's fairly transparent. So the issue becomes one of safety, not
Yeah.
environmental consciousness. So that's a good thing. We can, because of our sensitivity, I won't go into the details, but because of our cavity enhanced absorption sensitivity, we can detect hydrogen, even though it's a homonuclear diatomic molecule that's not supposed to absorb light. It does, and we can actually measure it. So we can convert the methane sensitive detection part by swapping out a laser, changing the software a little bit to analyze H2 spectra and not methane spectra, and do the same thing again. So it's just a swap of a laser, changing the software, of course, but then we're pretty much good to go.
That's fantastic. Hugely interesting. Unfortunately, we are out of time. It is 11 o'clock Eastern. Thank you, everyone, for tuning in today. And especially thank you, Doug, for this really great presentation and this really, really cool technology that I hope we see more of in the future.
Thank you,
Please
Randy.
connect with Doug on LinkedIn and follow ABB on Twitter at ABB Measurement. Please join the Atlantic Council Global Energy Center for a couple of events happening next week. On Monday, we'll host an event discussing community scale implementation of green urban design and climate action, 4 p.m. Eastern Monday. We're also hosting a virtual event. This is going to be very cool with Governor Jay Inslee, Governor of Washington State, and other climate leaders from Washington State to discuss the challenges and opportunities that come from the energy transition. That's Wednesday, April 7th at 2 p.m. Eastern. And then we have another innovation stream next Friday on the versatile test reactor. Thank you, everyone who helped put this event together, including Zeynep Wirinen, Peter Gonzalez, Maria Castillo, and Olga Kokova. Olga, thank you again for a year of fantastic effort. This presentation will be available on the Atlantic Council website, YouTube channel, Facebook, and Twitter. So please do share it with your colleagues. Thanks so much, and enjoy your April.